Welcome to the Unlocking Test and Evaluation Collaboration panel. I have a great set of panelists here with me today, so I want to take a minute and I'm just going to let them introduce themselves and tell you a little bit about what they do and their connection to this subject. I'm Marjorie Sensler. I'm the editor-in-chief of Aerospace America, and we are excited to be doing this, and we'll be taking your questions too, so if you have questions, please send them along and I'll try to incorporate them as we go. So first, I'm going to pass it to Bill Koyama, Senior Director at Northrop Grumman.
Thanks, Marjorie. So yeah, my background is really the operator, the user. I was in the Navy flying F-18s off the ship for 28 years. And went through Navy test pilot school in the middle of that, and then taught at a couple of test pilot schools, Navy and over in England. And then I kept going back operational, was Air Wing Commander of CAG-5 in Japan on the George Washington, and also had a lot of combat cruises in between there. But then I got out and I still wanted to fly, so I was joined Skunk Works and was at Lockheed for 7.5 years there in Palmdale, flying some stuff, mostly classified stuff, and then last 2 years, tomorrow is 2 years at Northrop Grumman. So now I'm test and evaluation for all of Northrop Grumman, so it's all the different platforms. And they do it a little differently because they don't just do flight test. So what's in test and evaluation owns the flight test, the production test, you know, on the production line, the lab test, which is huge, a lot of people. It's about 1,900 people in test and evaluation. So.
Thanks for being here. Pass it to Laura Freeman.
Hey, good afternoon, Laura Freeman. I'm the Deputy Director of Virginia Tech's National Security Institute, but really in my core, I am a tester. From very early ages of doing Pepsi challenges at every family dinner where we, try to do the side-by-side comparison test and collect data and come up with scales. But I've spent my career starting in grad school working for NASA, testing the Ares 1 solid rocket motor, carbon overwrapped pressure vessels for the space station, which really got me hooked on real tests, not just Pepsi challenges at the dinner table. And then from there, went to the Institute for Defense Analyses, supporting the Director of Operational Test and Evaluation, working all the major oversight programs, everything from command and control to medical healthcare records to the F-35 program, and thinking about kind of answering that question of how much testing is enough. And the reason I'm at Virginia Tech now is kind of seeing artificial intelligence, as I was still working very closely in the Pentagon, coming down the pathway, and digital engineering, modeling and simulation, and thinking about, with these new technologies, how do we think about tests differently? How do we leverage modeling and simulation in ways that we haven't before? How do we leverage digital transformation? And then how do we have methods to test AI? So that's a lot of the research that we do at Virginia Tech and the National Security Institute, and look forward to participating in the panel today.
Thank you. Jeanette Crappie.
So Jeanette Crappie, I am at Boeing for 30 years, so probably not related to government, but I have tested for commercial and military aircraft. So as a 30-year involvement in test, I've been both the test customer and the tester. So I started my career more in flight sciences and deriving the requirements for test. And then about halfway through my career, I decided I really liked playing with the hardware, and I switched over to test and being a tester. And so for 15 years, I've been flight test and lab test across all of our major Boeing products, being part of FAA certification, military certification, and working with our groups to grow our capabilities. So from, like you said, like lab test and flight test, so we have quite a bit of lab testing capabilities. So today I am the integrated test leader for mobility surveillance, bombers, and vertical lift, and so responsible for all of the testing within those programs.
Thank you all for joining me. As you can see, we have a lot of expertise, so we'll jump right in. Bill, I think maybe it would be a good place to start by talking about how your operational experience informs how you think about test. How do you ensure kind of that link doesn't get lost?
Well, it's a good question, and I would go back to the title of this is test and evaluation. So people lose the evaluation part, I think, a lot of times, and they're like, test, oh, there's a spec, there's a requirement, there's a number. Just go out and prove you can get to this number. But that's not the evaluation part, which has to be, it might hit that number, but is it usable by the warfighter, by the end user? And it's commercial, it's different, not a warfighter, but how do we do it? I mean, it's getting involved with the people that are going to be doing test and evaluation at the very beginning, as early as possible in the design phase. And it's not just kind of a one-off, and the relationship needs to continue through the CDRs and through the production and then into test. That both makes it go more smoothly and makes it more relevant to the end user. So it really, it's getting involved early and having the right people involved. And maybe you don't have a bunch of people that just freshly got out of the military or whatever, the users, but you have to get that expertise in there somehow. And design reviews is a good place to do it.
Anyone wanted to chime in?
Yeah, so I'll jump in because most of my career has been supporting operational testing, which really focuses on the operational user and the DoD test and evaluation community. And so really want to echo Bill's comments on the early involvement and bringing that kind of operator expertise early into the test and evaluation program so that you're getting that feedback loop is a really critical thing. And some of the programs that I've worked best, we were talking earlier, and where they co-located the development and the test and evaluation teams with an operational user base. I don't know, the space worked out or something, and having that really early and often feedback loop led to different design choices that still were all within the requirements, just small tweaks that really made all the difference. So I think that user involvement is critical to how we do test and evaluation.
I mean, it sounds like implicit in that answer a bit is also having your test and evaluation team working with your development team, right?
That's right.
And how do you ensure that?
That's right. I mean, from a test and evaluation perspective, it's critical that we start off in the early stages of development, right? So testing itself is its own discipline and skill, but to pair with our development teams, it really starts to drive out some of the real world applications from a test perspective, but also how can you test? How do you derive those requirements in such a way that we know that we're going to be able to verify them in the product itself? I think too, from a test team perspective, our test teams are a multifunctional team. We've got the pilots, we have the engineers, we have the data scientists, the technicians. And so as we start to look at how the design is coming together, we do provide operational feedback, like the evaluation piece of test and evaluation, so that when the product is coming together, we can give that feedback. Particularly from our pilots, our flight crew. They're in the sims, they're sitting with the design team when we're looking at the flight deck or the human factors, and they're providing the feedback of what works and what doesn't work and what's going through their mind as they're working through it. It's got to have that human and machine interface, and that's something that the test team can bring to the table very quickly, because that's typically what we do on the regular basis, right? We're in the product. We're either doing flight testing, we're in the simulations, and so we can bring that information back to the folks that might not necessarily see that on a day-to-day basis.
Yeah, and the last thing you want to do is get to op eval and have it fail, right? Because it's like, what have you been doing for 10 years? Or even if we get accelerated and we do it in 5 years, like, what did you do the last 5 years that you could fail op eval? I mean, so those are the end users, closest to being the end users, right? And I think what you said is important. You use the word holistic. That's how I think of it. I mean, I'm probably biased because I'm a pilot, but all the time flying the F-18, I didn't need to know necessarily about every beep and squeak of how everything worked, but I did have to know everything about the whole airplane. You know, what is the fuel system doing? What is the electrical power system doing? What is the engine doing? And I think that when you get to the test and evaluation part of it, you kind of you grow a cadre of holistic thinking people, because if they're not, they're just thinking about one component, like just an APU. It's like, do you know what the APU does? Do you know why we need an APU? And if they don't, that's where you can have disconnects and silos. So I think that part of the whole T&E community is to try to be holistic, think about the whole thing, and then that expands to think about the whole mission, not just even the whole airplane, but what is this whole thing going to do in the world when it gets out there? So, sorry, talking too much.
Yeah,
No,
to
you're
your
good.
point, Bill, I mean, even the fact that we talk about aircrew, but it's the maintainers, it's the life cycle of the product itself, right? So if it can't be maintained easily, that's going to draw out an impact operationally if it's going to be ready for mission or not. So it is holistically, like, how are we looking at the vehicle?
I also wanted to ask a little bit about the, the balance between model-based test and real life testing. I know, Laura, you hinted about that so in your opener, so maybe you want to take that one to start.
I was actually going to jump in on this conversation with how important this collaboration between system developers and designers and testers is, because of the push that we have for digital transformation to bring more systems engineering, model-based systems engineering, modeling and simulation into test. And I think that opens up lots of new opportunities, but there are big challenges in front of us. And one of the common things that I see is this concept that people think, well, once I have a really high fidelity modeling and simulation or digital representation of my system, which I like to use as opposed to digital twin, but it's a representation. Once I have that, I can start replacing test points one for one, and that's never going to be the case. These models are going to be really useful in informing tests, highlighting these areas where we have high uncertainty, understanding and characterizing how a system might operate across various operating conditions, operational envelope, if you will. But we're always going to learn something when we go put it in the hand of the operational user, conducting a real mission with various sea states if you're a ship, or environments if you're, the sea's harder than the air, but since this is AIAA. But various environmental conditions going on, you're going to learn things that weren't in your model necessarily and be able to update your model. And that collaboration piece is really important as we start to move forward with digital transformation. And I'll say from the work that we do on kind of the federal government side, our processes aren't there yet. How we feed test data back in to developers, how we get that operational context very early, we don't have that baked in our processes yet.
Yeah.
Oh, you go ahead, Bill.
No, well, I was just,
Yeah.
you made me think of, when do we do that? When are we learning that? It's like we have to learn it on a program. It's like programs are like trains, and they only come by so many times, and if you don't get on that train and then go, let's change our process, there's no money to just come up with a process. Like,
Yep.
but if you're on a train's going somewhere, and I think that's where we have to be ready, to jump on a program that is funded and make those changes and learn how to change the way we're doing model-based testing and get our feet in the water there.
Yeah.
Because we're not going to get our feet in the water when there's no train to ride on, I think.
Yeah. It's just an academic study, if you will.
Yeah.
But
once
I
you've
think
done
that's
it, once you've done it, it's like we just did that on this program. And it's like, we're
yeah.
always going to do that on every program.
Yeah.
And
But that does put a huge burden on some of the programs I've talked to where they don't have the task force that's equipped with model-based systems engineering. They don't have the tooling in-house. And so it's a lift for that program to get on board as well.
Yeah, exactly. I mean, I think everybody's looking at how can you use model-based engineering and how do you tie it together with test. It does start with the system engineering piece of it, though. And we need to start from the very beginning again and then bringing into the test. Having test models is great, and I think we're going to continue to evolve that. But the real benefit is going to be if you can get the system engineering requirements and feed it through the digital twin too, right? And how you get it to the other side and into the test. But I think the value of doing model-based engineering and bringing the tools with us is really going to accelerate the testing. I don't think it will replace real-life test, right? It will supplement it, but I think it should speed up the evolution of development, be able to iterate on the design quicker, find the errors faster, so that when we get it into some of the large-scale tests, when you're doing the software-hardware integration tests, the most expensive piece, right? We already have tested a lot of this information ahead of time, so then at that point, it should be more validation. But we have to get to the point, like you said, where we're on a program or when we're all using that data together. But there is a challenge in the fact that we are going to all have to buy into that data. Everybody needs to understand what that model is and what the data feeding into it looks like and how the data is coming out of it. Because if we're going to try and use it for certification, for showing that the product is safe and we have a quality product, it's everybody, it's industry, it's going to be the regulators, it's going to be the customer, has to truly understand it. And I think we're still working through, like, how does that work? How does it work on a defense program where we're putting in information and then we're presenting it to our customer to say, let's buy this off, right? I mean, we're still all learning together on that. That's part of this collaboration that we have to continue to work through.
So I think you said lots of great things, but something that really stuck with me was that it opens up the opportunity for the open air testing to be validation, as opposed to, I use the word characterization. When I'm thinking about planning a test, sometimes if I have to fully characterize it open air, that's a much more expensive proposition and is subject to high risk, learning things that you should have learned earlier. But if you have high fidelity representations of the system, we can then think about how do we plan tests so that it really is validating or helping calibrate those capabilities. And I think that is an important paradigm shift that we're about to make.
Agreed.
Ooh, one other thing you said in our prep session was that companies don't, the government by Title X owns kind of the independent test and evaluation. I think that comment struck me because I think that also has to change to enable this type of shift that you highlighted.
Yeah, that's kind of leading into my question is, it seems like the panel is in agreement that we're headed in this direction, but there's some challenges. What are the things perhaps that have to change to get there, and who needs to lead that effort?
You didn't prepare us for that one.
Well, I think the point I was trying to make about we gotta be doing these things on a program that's funded is, we should be doing it, right? And it's a relationship with, at least in the military industrial complex, there's some program manager. That program manager is, he's thinking cost, schedule, performance, which really is thinking cost, schedule, because schedule is cost. So really he's just thinking cost, right? And if he doesn't, he or she doesn't see the value in what you're doing to try to improve the process, they're not gonna stand behind it, or endorse it. And they need to endorse it with the customer that made the contract, right? Because they're buying the thing and it's the taxpayer paying for it. So it starts, I think, with us in T&E and the relationship with the program manager, because that program manager is the focal point for saying, let me do this for 5% of something, and then the second wave of testing that I need to do, it's going to go 15% faster, which is money for you, and it's quicker equipment to the warfighter. But they won't know that because not every program manager has been a tester. Not every program manager has been a user of the products that they are managing the program for. A lot have been very good at business, and they have business backgrounds, and they're good at profit and loss, and we need that. They need that, otherwise the company would die. But so it's the relationship with that program management, I think, to convince them, to show them how leveraging this and improving the process, advancing the field of the process is going to really make them money in the end, right? Because they're put there by the board or by the CEO to make money.
Yeah, I think the other challenge we have is if you look at the products that we have out today, and I'll just focus on some of like our military products. We continue to use our products for years and years, right? We're doing a re-engine of the B-52, which we talked about. We've got continuous iterations on our products today. Well, with these legacy products, we don't have the model-based engineering data, right? It was built on drawing 2D. And so when we look at a lot of the modernization programs, it's going to be pretty expensive to bring it into a model-based system. And so then the question becomes, well, how do we approach this for the products that we have out today, where we want to continue to iterate and continue to modernize and leverage and develop, but we're not necessarily going to go back and create a digital model for everything. So then what products, or where do you want to bring that in? How do you leverage that tool and look at the pieces where it might make sense and use that tool there, but you're also going to have to rely on the older data and continue to use processes and tools that aren't in the modern age, if you will. I mean, we'll bring a lot of them forward, but you don't always have that data, right? So it's always going to be a trade-off for a lot of the products that we have out today on how much do we put into a model-based system, and how do we use that through the data stream. And certainly you're going to want to use that, but at what point, and how do you blend those processes and tools together? I think that is a challenge for a lot of programs. Obviously, clean sheet programs, different. That's where you can get on the train and start from the beginning and really leverage those tools themselves.
So I think the combination of those clean sheet programs with an ambitious program manager to push things forward is critical. But also, I think there's some policy and guidance things from where I sit with the DoD that can help this. So, like the DoD has done a digital engineering strategy with the acquisition transformation strategy that they're looking at right now. One of the key things that they're looking at is extending the life of a program manager. Because a program manager, they cost, I love how you boiled cost, scheduled, and performance just down to cost. But it's true, and there's a upfront cost in going digital to programs, especially for legacy, but even for the new programs. Upskilling your workforce, building those models. And the first opportunity to get that return on the investment, as I see it, is in test and evaluation. But the long-term opportunity is really in the sustainment chain of those systems and keeping those updated. But that's not within a program manager's life cycle. And it's not within their cost control. And so extending their life cycle, I think, is a critical kind of policy piece that will have maybe desired positive downstream effects as well.
We're starting to get some great questions from the audience, so I'm going to take a couple of these. I see two that are both about this kind of model-based test and evaluation that we're talking about, so I'm going to present them as a pair, and we can maybe tackle them together. One is, many customers seem hesitant to accept model-based test and evaluation. How do we work to get our customers on board? And then another one is, one would normally expect flight test measured performance is considered truth. However, when our model-based predictions do not agree with flight test, how do we maintain acceptance that the data is right and the model was wrong? So we can kind of jump in anywhere on these.
I think you should talk about the
customer acceptance.
Customer, right? Because I think people will do whatever the customer says. We want you to do this, like, But my experience with at least with airworthiness authorities is they're not necessarily convinced yet, and you just got to show them something. So, but you're closer to.
Yeah, I agree. Like prototype and pilot and showing people things is how you start to build that adoption, and you don't start with airworthiness.
Yeah.
You start with things that are, are a little bit less safety critical, and show that you can do that, and then go collect the data and validate it, which also gets to the second question about when the data and the model don't match. Like, first of all, expecting them to match is never gonna happen, never gonna happen. And the data isn't necessarily, that is collected in flight tests or live testing, isn't necessarily better because it's often more limited. And the black swan problem, anyone who hangs out with statisticians like myself knows that there's a distribution and you can get a point from anywhere in there. And so when we treat that live test data as like that's the gold standard and all the modeling is wrong, we could be really, really wrong in making that assertion. So I think we need to kind of educate along those lines, but also focus on, what was the characterization that my model gave me, and where does my live data fit into that? Because, just as a simple, if I had a chart, I'd say, say my operating envelope when my model was defined in this space, and I go out and live flight test, and I find that it's, maybe just pulling in a little bit because I didn't think of a variable that defines that operating envelope. That's still a really good model. It gave me the outline. I just needed to test the edges. And so starting to think like that, I think, is critical for really enabling the adoption of model-based systems engineering, systems models, modeling and simulation, as maybe even a better source of information than live data, but calibrated with that live data.
I'll rebuttal a little bit of that. Because I think it's either way, right? Because I've seen where we have live data and it showed some anomalous trends, right? And the model didn't, and the engineers didn't expect it to show this, so it got discounted. And then you went further into the testing and realized it actually was a real phenomenon, and we have some problems. And so I think I'll answer it like a true engineer. We just need more data. Like, if the model doesn't match and the live data doesn't match, why? Like, now you start to get back into like the fun part of engineering where we're looking at, well, why? Go figure out what is driving the model, what is driving live data, and then how do we start to converge on the two? But getting different eyes on it and looking at the information, I think, is where you have to start. And because it's very easy to start to throw away a data point that doesn't look right, either in the model or in live data itself. And sometimes, a lot of times, it's the right thing to do, but there are times when it's not. And so I think we were talking in one of the previous panels around having those experienced engineers and really being able to understand the truth data. And it's those experienced engineers that know when to start digging into, that's something that we really, really need to go look at. So, both sides. Yeah.
Well, the question is about the models or data. I think data is not wrong. Unless
data.
instrumentation was broken or something. Data is truth, data is data, but it may not be understood correctly. So the interpretation of it, and then in the pilot community, we have the saying, all models are wrong, some models are useful. So
We say that in the statistics community as well.
but aren't we're getting closer to, like, some models might be right, at least to the molecular level, to where that's right, and the rest is noise. Like, it's not 100% right, but it's so 99.999 that we can use that. So it's, I think when they disagree, it's usually, unless there's an error with the instrumentation, something was broken, that it's somebody doesn't understand what input was put in there, or how to interpret that piece of data. But there's only one reality, I think, and it's
So far. Okay, I have a bunch of good questions. We'll get to as many as we can. We'll pivot a little. Testing is expensive. What future technologies might reduce the cost of tests and evaluation?
future technologies.
Future technologies. What could reduce the cost, you think?
Well, I think that what we're talking about, right? Model-based T&E, if you don't try to eliminate all the testing, but if you had 100 test points to do, and you can validate 10 of them with a model, that's significant. I mean, that's monetarily significant. That could be, you know, several flights or whatever, which is thousands and thousands of dollars. If there's things you can do where you don't need to go to a very expensive range because you can validate it with the model and you trust that model, that can save a bunch of time and a bunch of money and a bunch of risk too. There's always a risk of crashing something whenever you go fly. But I think that technology, and we talked about it a little bit before, is, in my opinion, models are out there, model-based T&E is growing, but the model validation is the first key to that, to trusting the model. So that technology of the validation of the model is where it could really accelerate that to a exponential way, not just a linear way. And then it's like, oh, we can get 25 of those test points or something.
Yeah. So echoing that, and then also bringing in the point you raised earlier about the long life cycle of our systems. If we can get to a place where we can validate models, that has really downstream effects for, you know, the systems that will be in place for 20, 30, 40, some of our systems like 50 years.
No, 100.
100.
Yeah.
Well, it's 2026, yeah. But kind of compounding that and why this is, like, it will save money in the tail, but also I think it's something we have to be doing now one way or the other, is the fact that most of our capabilities on our systems are now driven by software and soon will be driven by more artificial intelligence. And so that element of being, you know, plugged into the system means we can't do it all. We haven't been able to do it all in live flight testing for a really long time when you look at like the number of lines of code on our advanced complex systems. And so figuring out how we validate these models and then keep them validated, which in my mind involves some level of uncertainty quantification, and once you get outside of these bounds of where you're certain or, you know, probabilistically certain, then you have to go back and revalidate. But we need to have some kind of concept of how we keep models validated even as we're plugging in new software modules and artificial intelligence.
Yeah, the only other thought I was going to add was just the data itself, right? So I think when we start to look at the life cycle of a test and evaluation across any product, we generate huge amounts of data through the life of it. And so how do you keep some of that information as you, at least in the development phase, not maybe necessarily in the life cycle, but just in the development phase, how do you keep that data and be able to make it available for the engineers that are there? Because what happens right now is that when you're testing a widget, you're testing a component, you're testing a subsystem, the data is tested and it goes specifically to that engineer. Like, who's requested it, here's the data. And another engineer comes, tests it, and you give them that data. And it doesn't always get shared across the board. So we're looking at, like, how do you really create that data and have the metadata with it so you can use the data. So when you get to some of the real complex full-scale testing, that you have data that everybody can start to source and look at versus continuously test only specifically for one item. And that's going to open up the ability for us to be able to test in a more efficient way, and that you can also see the connections between the different types of testing and what it might mean for a related system. So I think, you know, with the model-based engineering and how we keep those models and how do we keep the data and the data is relevant, how do you keep the data when the product is being used and you have that source data again? I think there is a lot out there that from data scientists and AI and machine learning that will really open it up. And I am not one that can even talk that other than to say those acronyms.
Well, we have a question, to the magic word of AI, and we have a question about it. As AI tools become more ubiquitous, how do you see these being implemented into test and evaluation? Laura, maybe we'll start with you on this one.
Sure, I'd love to. So I think there is, we were talking earlier about test cards and just the generation of test cards. So I think there's everything from the documentation of how we do tests that AI can help accelerate. So support oversight, and so I've worked a lot with temps and test plans and review of those, generation of those documents, although I would like to get away from document-based things, but I think right now where we are, any kind of generation of document, where we are with generative AI, especially because we have this whole repository of guidance manuals and policy and all the ways that you're supposed to write this, when you have that context in generative AI, you can automate the generation of documents pretty quickly. So accelerating process parts of test and evaluation, making test cards to give to testers, but also thinking about how do we do the evaluation piece faster as well. So we've been playing around with how do we use generative AI coupled with trusted, validated scripts in Python and other statistical packages to accelerate the evaluation of test results. So I think there's a lot of opportunity for acceleration when we think about AI for T&E, and not just how do we test AI.
And I think just the, simple caveman, but just the basic stuff, like what are we basically using, Gemini or Chat GPT for? That'll just accelerate that test conductor gets the cards done a day earlier. Just like, well, we did something before we had Excel, before we had MATLAB, and then once we had that tool, it just could do stuff faster than you could do it with the slide rule. So I think we should push to get those models. They're not everywhere, right? And they're not behind firewalls everywhere that they could be and could be used carefully, slowly at first, I think, with experience, people checking the outputs. But I think that's one way we can get AI right away into just, streamlining tasks.
Right.
That gets the schedule compressed, which makes more money faster, I guess.
Right. Here's an interesting one. What's better, aligning T&E under one organization or aligning T&E to programs who have direct ownership?
Who asked that?
They're anonymous. These are anonymous.
Can I answer both?
Go for it.
So this has been debated in my field, I think, in companies for a long time in statistics. Do you have a statistics group or do you put your statisticians across the different mission owners? And I think where I've landed is both. You have to have a core group that has like the core methodologies of test, that understand how, best practices for, thinking about how much data is enough, calculating those probabilities, doing the evaluation, building dashboards, keeping on track of like the current state. But if you don't understand the mission, you don't understand how the user is going to use it, you're not going to design the right tests. So I think there needs to be kind of both elements within an organization overall.
I'll kind of draw on that a little bit. I think I'll say it a couple different ways. Test and evaluation in itself is an organization, or it can be an organization, but it is also a role of an engineer, right? So from an engineering perspective, I know our designers will also test their product. And so you have that embedded into the design and into the teams themselves. But from a certification perspective, in my opinion, it makes sense that you have a T&E organization that's separate from the overall embedded program. I think they absolutely need to be included, they need to be collaborative, they need to be integrated. But when you look at reporting structure and where you look at the autonomy of having testing, you want someone who is objective and who has the autonomy to say, I'm going to go test this product and I'm going to tell you if your baby's ugly or not. And it's hard if you're the designer to say it's ugly. And so I think there is a space where it's both, right? You are embedded, you are part of it, but in the end, as a tester, you need to have that objective viewpoint. You have to be able to test the product, test it the right way, get that quality data, but then be able to really lay it on the table and say, is this right or is it not?
I think the two things, most companies that are big companies, they'll say, well, we're a matrixed organization. Like we've developed that in the 60s to be Before that, they just had a company like, there's Kelly Johnson, he owns everything. He says everything that's gonna be, how it's gonna be. He's friends with the pilot, you know, and they flew around, but now we have Matrix, so we have, dude, this is what you're gonna do, this is how you're gonna do it. And the functions are how you're gonna do it. So the program doesn't tell manufacturing how to manufacture it. They don't tell engineering how to engineer it, and they shouldn't tell test how to test it. Those should come from the functions, but they're doing the work in programs, for programs. So I think it does need, I think one of you said both things, right? It still needs both things, but just like 30 years in the Navy, right? We go and we fight wars, we go do stuff, and when we're out in the fleet, we belong to the combatant commander that's out there. But when we come home, and in between when we get deployed, somebody else does staff train and equip. It's not the combatant commander who's getting the thing done, the war done. He draws upon, you know, our squadron or whatever to go hit these targets, do these things, i.e. test. But there needs to be another force that says, this is our standard, this is our standards for how you're gonna do this, you know, really the function of whatever that is, in this case, test and evaluation. And if you lose that completely, you're gonna go native, you know, because if you just work for the program, you're gonna do what the program manager wants you to do, and if what he wants you to do is cost, that's what you're gonna do. It's just normal human nature, I think.
Well, I don't know if our questioner is going to be happy with both, but that appears to be the consensus. Hila, I'm going to take another one. We're just getting a lot of good questions, so we'll keep going here. Government test infrastructure is often reactive and late to T&E needs. How can we drive that to be more proactive?
Sorry, can you say that government test is?
Infrastructure is reactive.
I don't know, that might be, yes, right. If the meaning for the question was infrastructure, like, well, what ranges are we gonna supply you?
Is anyone from TRMC here before I start talking?
Yeah. I mean, I think from reading also another question, I think that there's concerns in the audience both about the infrastructure and the culture piece of government and how one can adapt to that and cope with that.
I don't know. I guess I would say it this way. I mean, I know as part of some of our industry committee for test and evaluation as part of the National Defense Association, we've been talking a little bit about like where are we at from a test infrastructure standpoint, and you know, there's only so much money that goes around, frankly, and I see where from the government standpoint, they are building up some significant test capabilities that are leaning into like cyber ranges, hypersonic test facilities and ranges. And then we have some of our legacy testing that still the test facility itself is quite state of the art. But we also know, along with not just government, but in industry, the cost of maintaining the test infrastructure is large. And so there are ranges, there are locations that the internet doesn't work very well. The speed of the data processing isn't as great. And I think it's just a matter of, frankly, prioritization of where do we need to put the money for the infrastructure and where we don't. And I think that's also where we start to get into the industry, academia, and government collaboration, right? How do we take the money that's in the overall industry, if you will, and put it towards the locations and the test facilities that we need to advance the products themselves? And it's not like a one answer fits all. It's going to be along the way. Like, how do we work together to do that? And how do we then optimize the location so that we are spending the money and optimizing or modernizing the facilities that we really need? And maybe it's not that industry is doing it, maybe it's the government, but maybe certain test locations, it's going to be industry. And And how do we share the load? And I think that's partly what we're all trying to struggle with in some of the areas is where do we, from our standpoint, we're modernizing some of our wind tunnels. Well, that's because there are national assets that we know is going to be used. And so that's where we're going to put some of our money. There's many ranges that we're doing that in, but we know that there's other ranges, like I said, back to the cyber range, where that's going to be a huge multiplier from a test perspective, bringing all of our assets into the cyber ranges and being able to go and get that test data and be able to do that in an operational type environment. So it's not a great answer other than we all know that the test infrastructure is a challenge, and TMRC is working its way through it. Yep. Industry is working through it, academia is working through it, and I think we just need to make sure that we're putting the priority items at the top of the line versus lingering at the bottom.
Yeah, I think that's a really important point about getting the prioritization right, because I was going to say, one of the most useful things that's come out of the ICO is that informal collaboration on what the requirements are for test and evaluation. And coming back to the point on, you have to have a program to do it, that's kind of the same in tests as well. Outside of TRMC, there's not very large-scale investments in how do we do digital transformation for tests, how do we, bring more modeling and simulation to the table. And so having programs informing that is very important.
Yeah, I think that also if we can have a vision that spans more than one administration, we'll have, because, several years ago, I'm up at NASA Ames, because they're using a supersonic wind tunnel, right? And I was looking at this model of the whole complex, and it's amazing. Like, what brought to my mind though was we would never build that today. No one would build that today, but we did it in the 50s or whatever. Giant complex with all these connections and, supersonic wind tunnels, and, it takes all this power from the city and everything to run it. But where I don't know that anybody has the investment. Government built that, right? I mean, it was a government thing because they had a vision that we're going to need these wind tunnels in order to advance the state of, aerospace, and we want to be in the front of all that. So it costs a lot, but we're going to build this, and they did. I don't see that today because I think there's not a vision that spans administrations that's like a 10-year vision, or a 15-year vision, which goes by really quick. It sounds like a long time, but that's maybe 3 administrations. But if we had that, then without it being changed, every 4 years, I think they could get some more things done that build that infrastructure for us to use for test and evaluation anyway. So I think having that vision would help the government infrastructure be built for us to use.
Another question, software turn time is usually a critical path limiter. What is being done to make the design cycle quicker?
Who knows about software?
I was going to say, I think we're both looking at Laura.
I was looking at you guys because more the industry perspective. I think from a policy, governance perspective, we're putting in place the willingness to accept data from across the kind of whole developmental life cycle and the methods for being able to integrate that information to inform outcomes. But it is a challenge keeping pace with the software integration design. But I'm curious as to, from the industry perspective, where you're actually doing, I don't do software design, how that works.
I was going to say, software is not my forte.
Yeah, I don't know that I know a lot about software either, but I know that we have integrated flight programs in every airplane, right? Because every airplane is now software driven. The flight controls are software driven. And what makes us money and can make us more money is the labs and doing lab tests, because you can do lab tests with low risk and you can turn around if it doesn't work nobody died, nothing crashed, but, and then you go, oh, the software's not right. And you have to get the program and everyone to agree to build that lab, to test that software package, maybe with a SIL, so that it's software integrated with hardware in a lab. And I think that what I've seen is tons of risk and speed bought down because some investment was put in lab tests first, and they could run the software, they could test it, it doesn't work, fix something, test it, and until they get it right, then put it on the article to actually do testing out in the wild. So a little more investment in the labs, and that includes the software labs that are being created to run these things.
Right. I see another one I want to get to. Testing typically occurs in late-stage TRL design. What will it take to test earlier TRL tech at scale to learn and iterate faster?
I think there's multiple ways to look at it. I think if we're talking about, system integration type testing, the argument of being able to bring in small models or even test beds. Test beds themselves become the playing field, if you will, for being able to mature technology faster and being able to get it then to a state where we can get it to bring it into the full scale live testing versus if you're going to go and do it early, like radar testing, right? Go put it on a test bed and start using that after you do your lab testing, but go put it in real life before it gets onto the actual aircraft itself. And there's multiple ways to do that, and being able to do affordable test beds is important as well, so that you can put the experiment on, go run it, learn from it, quick iterate, and come back. And I think that's something that we look at doing. Like we have some of that capability, but I think it's also continuing to look at, can you do it in the labs? Can you do the models? So it goes back to even the beginning of the conversation around model-based engineering and how do we model it and run through it quicker and then get it into some of the small scale testing before we get to large scale testing.
Yep.
TRL.
When we talk about the systems engineering B, testing starts at the bottom, right? But we tend to think about that as just component level testing, and then we have system integration level testing, and then we finally go to like user acceptance.
Right.
And so getting through that cycle so it's not so flat of a V, but kind of faster, and using prototypes, using labs, using low fidelity hardware as we're thinking about the software components, just to get it in the hands of users. I've spent a lot of time thinking about test and evaluation of AI and designing the right AI for what you need for the capability. And one of the things that I've seen is we have waited way too long on some of our programs to test the AI in an operationally representative use case. And it turns out maybe we didn't design the AI that the operator really needed. And we just gave them, I like to call it dots on screens. And they're still just staring at screens all day, where we could have really re-engineered the process. But we didn't really see that until we went to that operational scenario. So thinking about how we can have lower fidelity integration test facilities really early is an important part of that.
There's another one about AI. Maybe I'll pass to you, Laura. With legacy products, will old data be able to be utilized with new AI models?
With legacy products, will old data be able to be used with AI models?
Basically, can we use older data? Can we use AI models to maybe model with what we have? And will there be an application there? Or is this really, I guess, what we were talking about earlier with the clean sheet? Yeah.
So I'll tackle that and kind of what I think it's thinking, because I like to make the joke that I've been down the big data rabbit hole one too many times, and I'm not going down again. Because we tend to think that we have terabytes and terabytes of data, and somewhere in this terabytes of data, there must be some bit of useful information. And then we send younger me, and then I send younger people down this big data rabbit hole and say, go find the thing. And it's never there. So I think there is a real opportunity to leverage legacy data, but only if it's well documented, high quality. You brought up metadata earlier. We understand the context, we understand how it was collected, what was the instrumentation. And I haven't seen data that looks like that much prior to like 2015. And that's just my personal experience. So going really far back in the legacy data, I don't see a lot of value for the AI, but one thing that generative AI is really good at is generating structure from unstructured data. So if all that context is there, I think there's a big opportunity to leverage legacy data. And one of the ways that I like to think about how do we leverage it from a test planning perspective is right now when we go design a new operational test coming from like what I've done, we bring a bunch of operators into the room, we bring the systems engineers, and we sit around the table and we say, well, what matters? What are they gonna have to do? And then we try and distill that down into some factors and think about what test conditions we're gonna have to run under. That's very human and manual process. How many drones have we tested over the years? I think there's a big opportunity in being able to pull test data from all sorts of surveillance drones and say, okay, what did actually matter? Can you tell me, based on what we've seen before, what's different about this one? All right, here's my test program, as opposed to being a purely SME-based activity.
Yeah, I was thinking of, there's data out there that we're not thinking about. Like, you're gonna put new engines on B-52, right? And so I don't think that the only data about B-52 is in a filing cabinet in a basement in Seattle, right? People are maintaining B-52s today, and they've been maintaining them for 75 years, or going on 100 years. There's data there, but are we thinking about that data, and can we mine it? It's from a different source than we would normally think of as, like, well, that's not in the flight test data for the original B-52, but it's data. Mm-hmm. It is data, and it probably could be useful in an AI model fed to it, but we got to realize that data is there, and then go harvest it, and I guess stick it all in the AI model and make it chew it.
Okay, we have a great last question, I think, for everyone. It's a good one from the audience. What changes have you seen in test processes and capabilities in your careers, and what do you think will be the next big advancement in test?
So I started in test officially in 2010, and my original job was trying to bring statistical thinking to the oversight operational test community, which is maybe not something that we thought about before. So design of experiments and getting better at capturing metadata and having structured data has been something that I saw in kind of the early part of my career, and really, that's also with, big data was like a term. People got excited about data science. Then we started to have all of these data competitions, which then evolved into AI competitions. And so just that appreciation of, I know testers have always appreciated how important that's what you do as a tester. You collect data and you analyze it. So, but that more general appreciation of data has been a really big part of what I've seen mature over the years in my career. And I do think that artificial intelligence is going to be something that really drives us in new directions going forward, especially when you intersect it with digital representations of systems, model-based systems engineering. Our group is already playing with, like, can we lower the barrier to entry on being able to do these things, coupling systems engineering knowledge with AI. So I think that will be something we see evolve in the next 5 to 10 years.
Yeah, I think to play off of that, absolutely the data. It's also some of the digitization, I can't talk, and automation of like our test processes and have it all embedded into the data system. And so having actually the system itself be a little more smart and be able to have the data collection and the way that we integrate taking the data from the aircraft and how we're even running through the tests themselves, where it's automated and we're grabbing the data and it's integrated together, has been a big advancement. We're still working our way through it, right? Just being able to get rid of the paper and being able to put it into, on an iPad or even beyond that, and having wireless systems in the aircraft itself and having the data from when we talk about distributed test operations. So having people from across the globe being able to participate in the test and understand what the testing is doing and being able to cue in on, hey, that data is what I need, keep going on it, right? Versus everybody's in the TM room and you have to be on site and it's 20 people and you have 2 hours and that's it. I think we continue to see that evolution of how are we going to be able to have the people that really need to see and understand the data involved in the test, being able to cue in where we need it, have it on their desktop, have the data immediately, process it on site, and we can roll into the next day. And so I think as we look at what you said around AI and the data evolution, how is that going to change tests? Because it certainly looks a lot different now than it did 30 years ago when you stood there and you had to hit a button, right? So.
Yeah, I mean, I'm really old, so, I learned how do you test the longitudinal characteristic? We'll do a pitch doublet, like a longitudinal pitch doublet. Okay, well, that doesn't mean anything anymore. So I've seen that evolve from that to like, well, it's a computer-controlled thing, so run a program or to find out flutter, right?
That's
and
charts.
because you can't do it, you can't do it precisely, but the machine can do it precisely. And then to run more complex programs to get that test done. And I think that the next evolution, besides just eliminating even needing to go do certain test points, but that does involve AI and the model-based T&E plan is if you're gonna test something that is a manned or human staffed thing, don't do it with a human first. First flight, let R2D2 do the first flight, right? And do the second and do some of the high risk stuff and the highest loads problems because we don't really have an appetite. It slows things down exponentially if you hurt people, right? But if something gets broken on a range, okay, let's fix it. So I think that's the next evolution of the tests. Let the machines do it. We got to check it. We got to evaluate it. And eventually it may be a thing that transports people and maybe actually a piloted thing, but that's the evolution that I've seen. Very manual to somewhat automated to let R2D2 do it and then give it back to me.
Right. Well, thank you to the audience for the great questions, and let's have a round of applause for our panelists.